Hey guys, welcome back from your awesome spring break. I hope you're ready to dive in. Today we're talking about applying the distance and midpoint formulas. So you may have seen these before, but hopefully this isn't something that's brand new to you. If it is, that's okay. We're going to go over it and we're going to learn it. And let's start diving in. Okay, so remember back in the day when you found slope, which is the steepness of a line passing through 2 points. And this is the slope formula. We say little m represents slope equals, and if the 2 points were x1 comma y1 and x2 comma y2, so any value of x comma any value of y for the first point, and any value of x comma any value of y for the second point. Then we break it down, and we know y2 minus y1 all over x2 minus x1 will give you that slope of the line. We also know that we found the length of a hypotenuse using the Pythagorean theorem, where remember when we have a right triangle, here's the right angle, the side opposite the right angle is always the longest side. That's called the hypotenuse, always the longest side of a right triangle. And we know that the Pythagorean theorem says that side a squared plus b squared equals c squared. Okay, so that's how we can find the distance of the hypotenuse using the other two legs, called the Pythagorean theorem. So here's where we get the distance formula. So let's just say, for example, I have this right triangle here. I'm going to redraw it. It's right down here. And instead of calling those sides just A, B, and C, I'm going to, instead of telling you how long those sides are, I'm going to give you some points. Okay, so this point right here, we'll call this x1, so that's our first x coordinate, and this is our y1. Well, if I know that this x coordinate is x1, I know if I go horizontally along that, it's not going to have the same x coordinate right here. So I'm going to call this x2 because that's going to have a different x coordinate, right? Well, I know if I go straight up from there, these 2 points here will have the same x coordinate because they're right on top of each other. So we say that this has the x coordinate of x2. All right, well, let's talk about this one. So if this is y1, do you see how going straight across, we didn't increase anything going up or down? So this has the same y coordinate as this point over here. But now if we go straight up from here, we know it is getting taller. So we call that as a second or a different y coordinate. Well, instead of side A being just a number, we call side A, the difference is between, I would take this value of x2 and subtract x1, and that would tell me how big A is. So I know A is x2 minus x1 because that's the difference of those 2 points that would give us the distance of those, of just that horizontal line. Same thing here for our B. So instead of this distance of B being given to us, we'd say, well, I know B is going to be the difference between the y value and this y value. So I know the B is going to be y2 minus y1. And instead of C, well, we can't say the subtraction of C. We know the C is right here. Well, here's the deal. This will give us our distance formula, and here's how. If I take the square root of this, it will give us that distance of C. So I know the distance of the hypotenuse, or really any 2 points, would be the root of x2 minus x1 squared plus y2 minus y1 squared. So that is our distance formula. Okay, so using this, we're going to find the distance of the line with the endpoints of 3, 5, and 4, 1. So the first thing I'm going to do is I'm going to go through here and I'm going to label it. This is my first point, so I'm going to label this as x1 and y1. And I'm going to label this one here is x2, comma, y2. And again, that just helps me differentiate between which point is which. This is my first point, so that's why I put the 1s on the x and the y. This is my second point, that's why I put the 2 on the x and the y. So now I'm going to plug in those values into my distance formula that I had. So I know distance equals the root of x2 minus x1 squared plus y2 minus y1 squared. So let's go ahead and plug that in. So here we've got x1 is -3. So when I see x1, so remember there's a minus in front of x1, so I'm going to put a -3 here. And x2 is right here, is going to be 4. So do you see how I just plugged it straight in? Square it plus, and now I'm keeping all of this stuff here because there's a minus here and a squared. So now I'm going to drop in, okay, well, what's y2? Well, y2 is -1, and y1 is right here, it's 5. So just be really careful with the negative sign when you plug that in. Don't forget that there's a minus in between no matter what, whether the number is positive or negative. So when I go to simplify this, well, I know in the parentheses, 4 minus -3 is like saying 4 plus 3. Well, 4 plus 3 is 7. And -1 minus 5 is a total of -6. So now when I start to simplify this again, I know 7 squared is 49, and -6 squared is positive 36. So when I do that, I take the square root, and I get, got to pull out my calculator here, is a square root of a total of 85. And that can't be reduced, that can't be simplified, so that's just how we're going to leave it. And it's perfectly fine to leave it as a square root as long as you can't reduce it. Okay, so you just plug in those values of x1, y1, x2, y2 into the distance formula, and you simplify. So what if we use that idea of the distance formula and we had to classify a triangle as scalene, isosceles, or equilateral? Remember that scalene means that all 3 sides are different sizes. Okay, and then isosceles means that 2 sides are equal, meaning one side is different. And equilateral means all 3 sides are equal. Okay, so in order to classify this triangle, we just have to find the distance of each side of the triangle. And then once we have the distance of each side, we can classify them as scalene, isosceles, or equilateral. So to look at this, we're going to say, well, I need to know the distance between A to B. So we're going to find the distance of AB. We need to know the distance of B to C. So now we're going to look for the distance of B to C. And actually, I'm going to make this orange because I highlighted that in orange. So the distance of AB. And then lastly, it's A to C. So this would be the distance of AC. So the first thing we want to do is make sure that we know what we're setting things up as, right? So I know from A to B, the points are 4, 6, and 7, 3. And again, just like I did before, I'm going to label these x1, y1, x2, y2. And I'm going to plug those into the formula. D equals the root of, and we're going to set this up so that we don't miss it. So remember, we go x2 is this one here, minus x1 squared plus y2, which is 3, minus y1, which is 6. And then we're going to simplify that. And we end up with 3 squared plus -3 squared to simplify that. 3 squared is 9, -9, or -3 squared is a +9 also. So we get this as the root of 18. Now that can simplify, but I'm just going to leave it the way it is just because the whole purpose of this is that we're just comparing. So I'm just not going to worry about simplifying it right now. Let's do the next one. BC. So the distance of BC, we have to use the points B and C. So the points for B and C are 7, 3 and 2, 1. So we're going to use those points and we're going to label them X1 and Y1, X2 and Y2. And we're going to say, well, we know the distance is, and I'm just setting this up because I know that each quantity is squared and there's a minus in the middle of each quantity and then a plus in the middle of the two. And I know it's going to go X2 minus X1 squared plus Y2 minus Y1. And there we've got -5 squared plus -2 squared, which is 25 plus 4. So that's the root of 29. So right off the bat, just comparing these two right here, root of 18 and root of 29, we know they're not the same. So I know for sure it's not an equilateral triangle. And then lastly, let's compare sides AC. Well, remember AC, we're using the points A, which is 4, 6, and C, which is 2, 1. And again, we label this as X1, Y1, X2, Y2. Let's plug this into the distance formula. So we say, well, we're going to go quantity squared plus quantity squared, minuses in the middle, and now we can plug stuff in. X2 minus X1, Y2 minus Y1. Simplify what we've got. 2 minus 4 is -2 squared. 1 minus 6 is -5 squared. And when I do that, I get +4 and 25. So I end up with the root of 29. So when I compare the three answers, I see that 2 of them are the same and 1 is different. So because 2 are the same and 1 is different, we call this isosceles. And that's how we classify them. You have to find all three sides. There's no faster way. All right, now let's go ahead and jump into the midpoint formula. So midpoint formula is actually super easy. Just think of it as taking the average or the mean of the endpoints of the points. So we know, same thing, if you've got 2 points, we've got an X1, Y1 for the first point, X2, Y2 for the second point, okay? And we use this formula. The midpoint is X1 plus X2. It's a little bit different than the distance formula in this way. That's an adding, all divided by 2, comma, Y1 plus Y2 all over 2. Because the midpoint means we're looking for a point. We're not just looking for a distance where it's one number. We're looking for 2 components because a point is written as an ordered pair. It's always going to have some sort of X, comma, Y. Okay? So we're going to do that. Okay, so we're going to plug it into that formula. And let's find the midpoint of -5, 1 and -1, 6. So again, I'm going to come back through and I'm going to label what we have here. So we've got X1, Y1, X2, Y2. And we're going to find the midpoint, which is, so I just set this up because none of this stuff changes. There's a plus in the middle. And everything's divided by 2. So now we go X1 goes right here, -5 plus X2, which is -1. And then we've got Y1, which is 1, and Y2, which is 6. Now we're going to simplify. And remember, we don't smush these together. The comma stays there. And we know everything's still over 2. -5 plus a -1 is -6. And 1 plus 6 is 7. So if we could simplify this, I know -6 over 2 is still -3. And 7 over 2, you can just leave it just like that. 7 over 2. And that is our midpoint. Just like that. And again, you want to have 2 separate answers because in our point, it's an ordered pair. We need to have 2 distinct parts, X, Y. Okay, new, and then now we're talking about something new. We're talking about something throwing back to geometry. a perpendicular bisector. So remember that? Remember those words? Perpendicular, remember, it means it makes a right angle, right? And bisector means it cuts something exactly in half. So in order to find the perpendicular bisector, for example, so let's say this was the line and I want to find the perpendicular bisector to A comma B. I would need to do two things. First, I need to find the midpoint, and I would need to find the slope that's perfectly perpendicular to a line AB. So here's how we're going to find it. We're going to find the midpoint of line AB, which we already know how to do. We're going to calculate the slope of the line that we're given, which we've done in the past. We'll review it again. We're going to find the slope of the perpendicular, which remember, the slope of the perpendicular is the opposite reciprocal of whatever slope there is. And then we're going to use the point slope form to write the equations. Remember, point slope form looks like this. It looks like y minus y1 equals the slope. Actually, I'm going to put that in red. The slope times x minus x1. Okay, so write an equation for the perpendicular bisector of the line segment joining A, B. So first thing we're going to do, step one, we're going to find the midpoint. So remember, the midpoint is x1 plus x2 over 2, y1 plus y2 over 2. And so we end up with, okay, let's go over here and we're going to label this x1, y1, x2, y2. Let's find the midpoint. So we're going to go set this up just like we did before. So we go x1, negative 3, x2 is 5, y1 is 4, y2 is 6. We end up with negative 8 over 2, comma, negative 2 over 2. If I simplify that, I get negative 4, comma, negative 1. So that's my midpoint. Perfect. So now we're going to calculate the slope of the line AB. So remember, slope is y2 minus y1 over x2 minus x1. So again, we're still got the same labels here. So we know y2 is 6 minus y1 is 4 all over x2 is 5 and x1 is negative 3. Don't forget that negative in front of the negative 3. So on the numerator, we've got 2. The denominator, x minus negative 3, is really adding a positive, so it's an 8. So if I reduce this, the slope is 4. Now, the third step is we find the slope of the perpendicular. So if the slope of the line is 1/4, the perpendicular slope is going to be the opposite reciprocal. So opposite means if it's positive, the opposite's negative. If it's negative, it's positive. So this is positive 1/4. So I know the opposite reciprocal is negative, or the opposite is negative, and the reciprocal of 1/4 is 4 over 1, which is just negative 4. Okay, great. Now we're going to use our point slope form. So we're going to go y minus y1. Well, remember, y1 is this right here, 4, equals m, which is, this is our slope for the perpendicular, negative 4, times x minus x1, which x1 is right here, negative 3. And there's an equation for the line. So if we want to clean it up a little bit, you can. You don't have to solve for y because this is a perfectly good equation. All right, and I'll see you back in class to do some of our practice.